Right. Today we're going to talk about probability 4, which is independent and dependent events. All right, we're going to find different probabilities. So, first one, it says to work with partner, we're just going to look at this as an example. All right, so with the dice and a coin, it says if one person rolls a dice, the other flips the coin, what's the chances, the probability that we roll a 3 and land on heads? So that means the only way we can get a success if the person one rolls a 3 and person 2 flips heads. That's the only success. Right? So that means if someone rolls a 1 and a heads, right, that's not good. Right? 2 heads. All right? 1 tails. 2 tails. So we want to find out how many total outcomes there are for this one success that we have. All right? So that's what we're going to be learning today. Okay? So it says when the outcome of one event does not affect the outcome of another, the events are said to be independent. All right, then we're going to find the probabilities of both occurring, multiply the probabilities of each event. So on the last page, all right, probability of rolling a 3, then getting heads. That means we have a probability of getting a 3 on a dice, 1 out of 6. Probability of getting heads, 1 out of 2. We're going to multiply them together. All right, so there's one successful outcome out of 12 possible. So this is our probability. All right, so this one says the bag contains 3 white softballs, 2 yellow softballs, 3 green, and 4 red. You reach into the bag without looking and take the ball out. This is important. You replace the ball and then take out another ball at random. Find the probability the first ball is red and the second ball is white. So again, we are going to find the probability that we get red, then white. So the probability that we get red, first we have to find the total number of softballs. So the total is 3, 5, 8, 12. All right. So red, there is 4 of them. Now you can simplify this or you can just wait. All right. And then we're going to multiply it times the second probability of a white softball. Okay, the white softball, there is 3 of them, so 3 out of 12. Okay, now you could just simplify or cross cancel to multiply. So 4 goes into 12 3 times, 3 goes into 12 4 times. So now we multiply straight across. 1 times 1 over 3 times 4. So the probability is 1 out of 12. 1 out of 12 times this would happen. Okay, so like it says, this is everything we just did. All right, got our answer. Okay, use the same bag of softballs. You reach in the bag without looking, take out a ball, you replace it. Again, this is important. Later we will not replace it. And take out another ball. Find the probability that both of the balls are white. So probability that we get white, then white. So again, if we look back, there are 3 white softballs. So that means we have 3 out of 12 chances of getting a white one. Once we get a white, then we would multiply it, and we want to see if we get another white. That's 3 out of 12 again. So we can cross cancel or simplify. 3 goes into 12 4 times. Both of them are 1 over 4. Multiply straight across. 1 times 1 is 1 over 4 times 4, 16. 1 out of 16 chance. You'll leave all your answers as fractions today. All right. Next one. When the outcome of one event is affected by the outcome of another event, it's said to be dependent. Okay. So independent or dependent. Tossing a coin twice. Right. Well, it's independent because the outcome of the first does not determine what the outcome of the second is. It says picking 2 marbles from a bag without replacing the first one. So that means, like the softball problem, we pick a white softball, then we don't put it back in. So that means the outcome of the first one is affecting the second one, so it's dependent. Choosing a captain and then choosing a co-captain. So if we have a room of people, right, 10 people on a team, you pick a captain. Now there's only 9 people left to choose a co-captain, so that is dependent. Rolling 3 dice, you roll 3 dice. It doesn't matter what each of them are. That's independent. Okay, 6 teams, the Panthers, Tigers, Lions, Bears, Cheetahs, and Elephants, great names, are in the lottery round for this year's draft. So this is just like baseball draft or NFL draft. To determine who gets the first lottery pick, one card will be drawn at random and then not replaced. Right? So it's not replaced because that team is getting that pick. The second card will be drawn at random for the second pick, and so forth and so on. So it wants us to find the probability that the Bears get the first draft choice and the Lions get the second draft choice. Okay, so just read this. It says, because the first card is not replaced, all right, sample space for the second drawing has been changed, so this is a dependent event. All right, so the probability that we're trying to find, again, probability that the Bears get first, all right, and then the Lions get second, and again, we are not replacing, all right, that team. Okay, we are not replacing. So the probability the Bears get picked is 1 out of 6 because there's one successful team, the Bears, out of 6 total teams. All right, then we're going to times it. Now the Lions, they're only one team. They only have one card, but now there's the Bears were picked. So now there's only 5 teams left, so we have 1 over 5, all right? And we just multiply them together, and the probability of this happening is 1 over 30. 1 out of every 30 times that this would be conducted, the Bears would get the first pick, and the Lions would get the second pick. Okay, Basketball League is drafting teams for a new season. The names of 10 All-Star players are written on cards and placed on a box. 2 of the players, Maggie and Sonia, are the team called the Lasers, get the first 2 picks. The coach will draw one name and not replace it, and then draw the second name at random. Right? What's the probability that Maggie will be the first choice and Sonia would be the second choice? So again, probability that Maggie, then Sonia, and again, the names will not be replaced because once they're picked, they're picked. So Maggie is 1 player out of 10. All right, if she gets picked first, Sonia is 1 player, but there's only 9 remaining. So that means the probability is 1 over 90. All right, today we're just multiplying all of our probabilities. All right, 1 in 90 chance Maggie gets picked first and Sonia gets picked second. All right. Last thing, all right, a bag contains 3 green marbles, 2 red, 4 yellow, and 1 black. 2 of the marbles are taken out at random from the bag without replacement. So we're finding the probability that we pull a green marble, then another green. So again, find our total, all right, our total 3, 5, 9, 10 marbles, okay? So probability that it's a green. So if we get a green, it's 3 out of 10. Assuming we take a green, now there's only 9 marbles left because we are not replacing it, and there's only 2 green left because we already pulled one. So notice how our chances change from 3 out of 10 to 2 over 9, and then we just multiply them. All right, so basically again, first marble, like I just said, 3 out of 10. Second marble, there's only two left, all right, that are green. Now 9 marbles. Multiply the probabilities. You can cross cancel or cross simplify. So that's what I would do. I would take 3 goes into 9 3 times, 2 goes into 10 5 times, so 1 times 1 is 1 over 5 times 3, 15, and that is your probability. Okay. Last page, same bag of marbles. So we have 10 total. Find the probability of 2 that are taken without replacement. So again, we're not replacing them, right? Probability that they'll both be yellow. Probability that yellow, then yellow. So on this side, let's look how many yellow we have. All right, 4 yellow marbles. So we start with 4 out of 10 times, if we pull a yellow, there's only 3 left out of 9. These are a little better odds. 1 out of 3. 2 goes into both of these, 2 over 5. 2 times 1 is 2 out of 5 times 3, which is 15. That's your probability. Assignment is on Canvas. All right, just the worksheet. Probability for worksheet, we're going to do numbers 1 through 19.